Ian, and many others like him, have asked this intriguing question: what would happen if we drained Earth's oceans and poured all that water onto Mars, specifically on top of the Curiosity rover? How would Mars change as the water accumulated? In a previous What If, we opened a portal at the bottom of the Mariana Trench and let Earth's oceans flow out. For the sake of curiosity, we funneled them all the way to Mars. Since the Curiosity rover has been working tirelessly to uncover evidence of liquid water, I figured, why not give it a hand? The thing is, Mars does have water, but it's mostly frozen. Liquid water doesn't stick around for long there, due to Mars being far too cold and having far too little atmosphere. Prior to our watery intervention, Curiosity's sensors were recording temperatures ranging from -100°C to 0°C, with the ground occasionally hitting slightly above freezing. Let me show you something. This is a phase diagram for water. The line you see represents the average atmospheric pressure on Mars, which, by some cosmic coincidence, intersects almost perfectly with the triple point of water. This is the point where water can exist in all three states: liquid, gas, and solid. Technically, liquid water could exist at Mars's lowest elevations, but only on warmer days. Low elevations have higher atmospheric pressure, but most of the Martian surface sees water either frozen solid or sublimating directly from ice to vapor. But now, we're dumping an enormous amount of water at once. This won't freeze solid right away. Mars isn't that cold. Earth's North Pole sees average temperatures ranging from -30°C to 0°C, and it's only the top layer of water that freezes because ice acts as a decent insulator. Plus, the water we're dumping is salt water, and salt lowers the freezing point slightly. Now, if we look at Mars, Curiosity is sitting in Gale Crater, a depression with the peak at the center, nicknamed M-sharp. Our water is pouring in rapidly, which is turning Gale Crater into a massive lake, just like you'd expect on Earth. As the water keeps flowing, the lake deepens, and Curiosity finds itself submerged under hundreds of meters of liquid. Oddly enough, this water would freeze from both above and below at the same time. The Martian surface is already below freezing, so rocks and soil freeze together, forming ice dirt chunks that break free and float to the surface like icebergs. Eventually, M-sharp becomes an island in this ice-covered water, but the water doesn't stop there. Before M-sharp is fully submerged, the water spills over the northern rim of Gale Crater and begins flowing across the Martian sand. It moves downhill toward the North Polar Basin, and in doing so, it forms a layer of sea ice and rockbergs, chunks of rock floating in the frozen ocean. On Mars, when water releases in real life, it usually sublimates quickly, freezing and turning into vapor before it can spread far. But we've got oceans of water now, and as it pours in, it gradually fills the North Polar Basin, covering the Phoenix and Viking landers unless, of course, they're trapped in the ice, floating to the surface like little icebergs. Looking at the rest of Mars, we see there's still a vast amount of land from the water. I've always been a fan of maps, spent countless hours studying and drawing them, but this one, kind of boring at first. It's a huge expanse of land with a bit of ocean at the top. But fortunately, we haven't come close to running out of water yet. Soon enough, the water begins to fill the Valles Marineris, creating some interesting coastlines. The water reaches other Martian landers, pushing them south. Eventually, the water spills into the Hellas impact crater, the lowest point on Mars, and Perseverance is likely destroyed in the ensuing cascade of ice, rock, and water. The more I look at the map, the more I think it's starting to look pretty good. Those crinkly coastlines? Excellent. If this were a fantasy novel map, I'd spend hours trying to figure out where my kingdom would be. The southern hemisphere starts to break up into large islands, and many smaller ones form too. And this is where it gets even more interesting. The high southern plateaus are soon covered, leaving only a few islands poking through the water. At last, the flow stops. The oceans back on Earth have drained, and unfortunately, the rovers are now out of warranty with significant water damage. Olympus Mons and a few other volcanoes are still towering above the water, their peaks more than 10 kilometers above the new sea level. The oceans would last a long time on Mars. The surface is already made up of at least 2% ice by weight, and that ice is slowly transported toward the poles through sublimation and atmospheric circulation. This process is incredibly slow, but with the amount of ice we've added, it will build up thick layers on top of the liquid water. Eventually, those oceans would freeze solid, and the ice would gradually sublimate to the poles. But there's an interesting twist. Water is a potent greenhouse gas. With so much new water evaporating into the atmosphere, perhaps Mars could warm up enough to keep the oceans from freezing, just like Earth's did. There's only one way to find out. If you enjoyed this story, make sure to like this video, it really helps us out. Share it with friends who'd love to learn something new, and subscribe to the channel for more fascinating content like this. Don't forget to turn on notifications so you never miss an update. Thanks for watching, and I'll see you in the next one.